This video is basically a review of the 4 conic sections that we've worked on so far. We've talked about parabolas, circles, ellipses, and hyperbolas. And so the first step will be that you will have to decide which of the 4 conic sections we're looking at, and then we'll go on to write the standard form equations and graph them. But first of all, if all you see is a general form equation, like you see in number 1 and number 2, the first thing you need to understand is all you really have to pay attention to in terms of classification are the squared terms, x squared or y squared. The rest of the terms don't matter in terms of just identifying which one of these 4 things it is. So let me just quickly go through a few clues that will help you immediately identify what shape you're looking at. For a parabola, you're only going to have one variable squared. Okay, so for example, you might have 3x squared, and then that'll be the only thing squared. You know, maybe the y term is just a 2y, but you're only going to have one variable squared. You know it's a parabola. For the rest of these, all of the rest of these, you're going to have both variables squared, x squared and y squared. So I'll just say for all 3 of these, you're going to have an x squared and a y squared. So the rest of this is going to be about the coefficients of the x squared and the y squared. For a circle, both coefficients are the same. So for example, if I had 3x squared plus 3y squared, okay, then I would know that I'm looking at a circle. For an ellipse, you have different coefficients, but the signs have to be the same. So for example, I'm going to go back to this. Say if I had 3x squared and then I had 2y squared. Okay, so they're both squared, and the coefficients are different. If these were both 3's, it would be a circle, but I have a 3 and a 2. That's what makes it an ellipse. Now it's important that they have the same sign. Either they're both positive or they're both negative. Because as you're about to see, if the signs are different, that's going to make it a hyperbola. So if the coefficients of the x squared and y squared have different signs, then it's going to be a hyperbola. For example, if I had 3x squared minus 2y squared, that would make this a hyperbola. Or if it was negative 3x squared and a positive 2y squared. If the signs are different, then that automatically makes it a hyperbola. So let's just start by going through and classifying each problem. For problem number 1, as soon as I see that only one variable is squared, I know that this is a parabola. So number 1 is a parabola. On this one, I see that both variables are squared, so it's not a parabola. I see that both coefficients have the same sign, so it's not a hyperbola. So that means it's either a circle or an ellipse. Because the coefficients are different, that makes it an ellipse. If it were a circle, these would both be 9, or they'd both be 25. So I know this is an ellipse. Okay, looking at this one, I see that x is squared and y is squared, so it's not a parabola. However, the signs are different. I have a positive 9 and a negative 16. That immediately tells me that this is a hyperbola. On this one, only one variable is squared, so I know it is a parabola. Okay, and I guess that's it for just equations. So no love for the circle today. Again, if it was going to be a circle, both variables would be squared and the coefficients would be the same. So no circles today. Maybe in that word problem at the end is talking about a circle. So for problem number 1, we need to rewrite this in the standard form for a parabola. We notice that the x is squared, so I'm going to leave the x terms on the left side of the equation, and I'm going to move the y terms over to the other side. So that's going to give me x squared plus 6x is equal to negative 8y minus 49. Now I'm going to complete the square. Half the middle squared, so half of this is 3. 3 squared is 9. So I need to add 9 to the left, and I need to add 9 to the right. This is going to factor as x plus 3 times x plus 3 is equal to negative 8y minus 40 as I combine my like terms. So this is going to make x plus 3 squared. Now I'm going to factor out the negative 8, and that's going to leave me with y plus 5. So this is the standard form equation for my parabola. All right, do they give me a place to write the equation itself? All right, I guess not, so I'll just put a box around that. This is the standard form equation. So the vertex of the parabola is going to be the opposite of this one and the opposite of this one. So it's going to be negative 3 comma negative 5. So that tells us that the vertex is going to be here. So negative 3, negative 5. This is the vertex. Okay, now this number right here tells me a couple of different things. Because it's negative, that tells me that this is a downward facing parabola, like this. So I know that if this is the vertex, then in some kind of way the parabola is going to be facing downward like this, which tells me that the focus is going to be down here somewhere. But where? Where will the focus be? Well, that's also something that I can get from this number. All right, the number in this position is 4p. So 4p is negative 8. If I divide both sides by 4, that tells me that p is negative 2. This tells me where the focus will be in relation to the vertex. So this tells me that the focus is down 2 from the vertex. Okay, so the focus is down 2 from the vertex. Alright, so let's take another look at that picture. So if here's the vertex, that means the focus is going to be right here. So the coordinates are negative 3 comma negative 7. So let's write that down. So the focus is negative 3 comma negative 7. All right, now to make this graph even better, here's something else that this negative 8 tells us. As soon as I can get my right color. Okay, this negative 8 tells us the focal width. Alright, the focal width comes from this number, but the focal width is always positive. So even though this is a negative 8, the focal width is actually going to be a positive 8. So the focal width is the width of the parabola at the focus. So that means that we can now do a better job at sketching this parabola. So we know it's facing downward, but instead of just drawing it in a haphazard way, we know that the focal width is 8. So at the focus, if I go 4 in this direction, and if I also go 4 in this direction, then that's a total width of 8. Focal width is 8. So this gives me a better sense of what the parabola looks like, a more accurate sketch. Okay? Now, so we've got the focus. The directrix is the same distance away from the vertex as the focus is, but it is in the opposite direction. So the directrix is a line. So if the focus is 2 down from the vertex, then the directrix will be 2 up from the vertex. So it will be this line right here. This is the directrix. Alright, now horizontal line is always going to have the equation y equals something. Okay, so it's always going to be y equals, and because it is at -3, then we will say y equals -3. Eccentricity. We never talked about eccentricity as it pertains to a parabola, but I will just tell you this. The eccentricity for a parabola is always 1. Now, so you can just memorize that. So let's move on to number 2. This one is going to be an ellipse. So in order to rewrite this in standard form, I need to group my x terms together. There's only one y term, so I don't have to worry about that. So when I begin to rewrite this, I will write 9x squared plus 18x. That's 18. Didn't do a very good job on the 18. And then I will put the plus 25y squared. This negative 216 will have to be added to both sides, so it's going to wind up over there. So now I'm going to begin to complete the square, but first this coefficient of 9, that's going to have to come outside of the parentheses. So dividing everything by -9 gives me, by 9 gives me 2x. I'm going to leave space to complete the square. All right, 25y squared. This is just a single term, so there is no completing the square there. So when I complete the square, I'm doing half the middle squared. Half of this is 1. 1 squared is still 1, so I add a 1. This is really 9 times 1, so I'm going to add 9 to the other side like that. So this is going to factor as 9 times x plus 1 times x plus 1. And then I've got plus 25y squared is equal to 225. So this x plus 1 times x plus 1, I really can just write this as x plus 1 squared. So for an ellipse, the standard form always has equals 1 on the right-hand side. So I know I'm going to have to divide everything by 225 to get the 1 over here. Okay, how many times does 9 go into 225? I bet it goes in 25 times. Yep, 225 divided by 9 is 25. So this is going to be, and I think I'll put it off to the side here. So this fraction reduces down to 1 over 25. So I'm going to have x plus 1 squared over 25. Okay, and of course that means 25 goes into 225 9 times. So this will just be y squared over 9. And this is going to equal 1. So this is the standard form equation of this ellipse. So to graph this, we need to start with the center. the center is going to be the opposite of this, and, well, this is just going to be 0. So I'm going to have -1, comma, 0. So the center is -1, comma, 0. Let's go ahead and graph that. So -1, comma, 0, this is the center right there. Now, it would be useful to have the a value. So for ellipses, the bigger number is always a squared. All right, the bigger number always leads to the vertices. So I know that a squared is the 25. So therefore, a is 5. Notice that the 25 is the denominator of the x term. So I will do plus or minus 5 in the x direction. And these will be my vertices. So I will go 5 to the right, and I will go 5 to the left. These are my vertices. So -6, comma, 0 and 4, comma, 0, vertices. Okay, now let's find the covertices. For ellipses, b squared is always the smaller denominator, so that means that b is 3. Since the 9 is in the y term, I will do plus or minus 3 in the y direction. So I will go up 3 and down 3, and these are my covertices. So -1, -3, and -1, +3. Those are my covertices. Okay, I could draw the ellipse right now, so I think I shall. Just get that out of the way. Okay, so there's my ellipse. But we also need the foci. So for an ellipse, we know that c squared is equal to a squared minus b squared. For a hyperbola, this is plus, but for an ellipse, it's minus. So the c value will lead me to the foci or foci. So I'm going to go c squared is equal to 25 minus 9. So c squared is equal to 16. So c is 4. All right, so that c value will lead me to the foci because I will go 4 away from the center. So if I go 4 to the right, that's going to put me right here. If I go 4 to the left, that's going to put me here. So my foci are -5, comma, 0 and 3, comma, 0. All right, is that what I said? Yeah. So those are my foci. There's no asymptote, there's no directrix. The eccentricity. The eccentricity is for an ellipse is the c value over the a value. So that's going to be 4 over 5. For an ellipse, the eccentricity is always less than 1. So we know number 3 is a hyperbola. We need to group the like variables together. So for example, I've got 9y squared and I've got -36y. Those need to go together. I've got -16x squared, +9x. Those go together. This constant, -252, that needs to go to the other side. I'm going to make sure that the positive squared term is first. So I'm going to put the 9y squared first instead of the -16x squared. So next comes -36y. And now I will put my x terms. So negative 16x squared plus 96x equals 252. All right, I added that to both sides. So before I can complete the square, I need to pull these coefficients outside of parentheses. So I'm going to pull this 9 outside, which means I'm dividing everything by 9. So I'm going to have negative 4y. Now I leave a space to complete the square. I need to pull out this 16. Now I'm dividing everything by negative 16. Let's see, 96 divided by 16 is 6. So this will be negative 6x. Leave a space to complete the square. So now I complete the square. Half of the middle squared. Okay, half of this is negative 2. If I square it, I get positive 4. But this is really 9 times 4. So I need to add 36 to the other side. Half the middle squared. Half of this is negative 3. If I square that, I'm going to get 9. But this is really negative 16 times 9. So that is really negative 144. So if I factor this, I'm going to have 9 times, and this will be y minus 2 times y minus 2, or y minus 2 squared. Then I'll have minus 16, and this will be x minus 3 squared. Now I need to add these three numbers together. So I'm getting 144. Standard form of a hyperbola will always have equals 1 on the right-hand side. So I know I need to divide everything by 144. Okay, so I just need to simplify this down. How many times does 9 go into 144? 16 times. So this reduces down to y minus 2 squared over 16. And so 16 goes into 144 9 times then. So this will reduce down to x minus 3 squared over 9 equals 1. So this is the standard form equation of the hyperbola. So the center is going to be the opposite of these two, but remember the x-coordinate is going to come from the x part of the equation. The y-coordinate is going to come from the y part of the equation. So there is the center. And let's graph that. So that's 3, 2. So there's my center right there. All right, to find the vertices, I need the a value. The first denominator, the positive denominator, is always going to be a squared. So I know a squared is 16, which means that a is equal to 4. Because the 16 is with the y term, I'm going to do my plus and minus 4 in the y direction. So starting at the center, I will go up 4 and down 4. These are my vertices. So that's 3, negative 2 and 3, 6. All right, for the covertices, I need to find b. So I know that b squared is going to be the second denominator. So that means b is equal to 3. Because the 9 is with the x term, I'll do my plus and minus 3 in the x direction. So starting at the center, I will go left 3 and right 3. So that's 0, 2 and 6, 2. So those are my covertices. The covertices, well, if I draw a rectangle around my vertices and covertices, that will show me where the asymptotes go. So I'm just going to draw a dotted rectangle through the vertices and the covertices. all right, that tells me that the asymptotes will go through the diagonals of this rectangle like this. So that gives me enough information to draw the hyperbola. So these red dots are the vertices, so that means the branches are here, and they must approach the asymptotes like this. So this is what the hyperbola should look like. So what else do we need to label? Oh, yeah, the asymptotes. So the model or formula for the asymptotes goes like this. It's always going to be y minus k is equal to plus or minus m times x minus h. This is the point slope form for the equation of a line. M is the slope, and then you substitute in a point. I'm using h and k because I'm always going to use the center of the hyperbola. That's the only point that's on both asymptotes, that's why I use it. Since the center is 3, 2, okay, right? Then I'm going to put 3 and 2 in for h and k. So let's see, the k, that's the 2. So I'm going to have y minus 2 is equal to plus or minus. M is the slope. So look at this portion of the graph, for example. All right, the portion of the graph that goes right here. What's the rise and what's the run? It seems to me that it is going up 4 and over 3. Okay, so 4 over 3, that's the slope. So that's why I'm going to put plus or minus 4 over 3. Okay, and then I need x minus h. All right, so I'm going to use the x coordinate, and I'll say x minus 3. There is the equation of the asymptotes. All right, eccentricity. That is always going to be the c value divided by the a value. You know what, we haven't found the c value yet, which we also need for the foci. So let's go ahead and calculate that now. For a hyperbola, we know that c squared is equal to a squared plus b squared. For an ellipse, it's minus, but for a hyperbola, it's plus. So that means c squared is going to equal 16 plus 9. So c squared is 25. So c is 5. Okay, so I can write the eccentricity now. C over a, that's going to be 5 over 4. And I can also plot the foci. So I'm going to take my c. C is the distance from the center to a focus. So if I go up 5, there's a focus. If I go down 5, there's a focus. So 3, negative 3, and 3, 7. All right, I think that is going to be it for problem number 3. Because the y is squared, I know I need the model of a parabola that goes y minus k squared is equal to 4p. Whoops, I said 4p, but I didn't write the p. Is equal to 4p times x minus h unsquared. So this is the model that has y squared and x not squared. So that's why I know it's going to be this way. To make this happen, I need to have the y terms on the left side of the equation, and I'm going to need everything else to go to the right-hand side of the equation. So this negative 8x and the 25, they both got to go. So I'm going to add 8x and subtract 25. That's going to give me y squared minus 10y is equal to 8x minus 25. Time to complete the square. Half the middle squared. Half of this is negative 5. If I square it, I get positive 25. I'm going to have to add 25 to the other side to balance out that change. This will now factor as y minus 5 times y minus 5. Over here, the 25s cancel out, so I just have 8x. So I can write this as y minus 5 squared is equal to 8x. So that's it. This is the standard form equation. Now I'm going to use that to write the key values. A parabola has a vertex. As soon as I see that the y is squared, I know that this is the type of parabola that will be sideways. So it's either going to open to the left or to the right. When the x is squared, that's when it's vertical. This will either open left or right. Because the 8 is positive, I know I am looking at a parabola that opens to the right. That means there will be a focus in the interior and a vertical directrix in the opposite direction. So let's talk about what the vertex is. In other words, the coordinate of this point right here. Well, looking at the original model, the vertex is always h comma k. So the opposite of this and the opposite of this. So that's why my vertex is going to be 0 from this, comma, positive 5. Because I didn't have anything added or subtracted with the x, I know it's going to just be 0. But the negative 5 becomes a positive 5 y coordinate. So let's go ahead and graph that. So 0, comma 5 is right here. That's my vertex. Now I need to find the focus. To find the focus, it will be helpful to consider the value of 4p. All right, see this 8? That is 4p. So 4p equals 8. Dividing both sides by 4 gives me p equals 2. Now I know that the focus is to the right of the vertex. Now I know that the focus will be exactly 2 units to the right. So if I start at the vertex and I go 2 units to the right, this is the focus. If I go 2 units to the left, that will be the directrix. So here's that vertical line I was talking about. Go ahead and draw it as a dotted line. So I can almost see the parabola opening to the right around this focus. But I need 2 more points to graph this accurately. For that, I'm going to use something called the focal width. All right, the focal width is very closely associated with this 4p. See this 8 in the front? Okay, the focal width is going to be 8. The only thing is, even if this had been a negative number, I would still say positive 8 for the focal width. Now the focal width means that the width of the parabola at the focus is 8. So if I go over to the focus, if I go up 4 and down 4, that gives me a focal width of 8. So that's enough information for me to draw the parabola. So the parabola goes like this. All right, see how I use the focal width? All right, so that's it. I've now graphed the parabola. Now let me write down any information that they wanted. I already have the vertex. Okay, so I don't need to write that again. Co-vertices, that's not a thing for a parabola. Focus. The focus is at 2, 4. 4. No, 2 comma 5. Asymptote or directrix. The directrix is this vertical line. Vertical lines are always x equals something, so x equals -2. Eccentricity. Eccentricity is not something that we normally find for a parabola, and it's because we just know that the eccentricity for a parabola is always 1. You can just memorize that. So that's it for this. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.